Hey everyone. Thanks for joining us for another episode of AKS Labs. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our host for today. Diego, thank you so much for joining.
Thank you, Anna, for having me. So today's presentation is going to be on Istio Service Mesh on AKS. Um, if you have done cloud native for the past years, you've probably come across the topic of service mesh. I mean, it's likely the number one topic that we keep hearing about. I've been part of the global black belt team doing cloud native for a little while now, and that's likely the one hot topic that my customers keep asking, like, hey, when can I do XYZ, or when will a service mesh, and typically Istio, will be available. Well, the great news is that if you are using Azure Kubernetes Service today, you can use Istio as an add-on straight out of the box. So we have support for that. Let's um, let's talk a little bit about what Istio is, what it does in this hands-on lab, and then by the end of it, you will have some hands-on experience with Istio on AKS. I'm going to show you how to secure an application. I'm also going to show you how does it work when I actually have something called a gateway API, which is somewhat new, and it's an amazing set of technology that we have, and Istio for sure supports that. So let's dive into this lab here. In a nutshell, Istio provides you with a service mesh. So we're talking about service mesh at this level here. It means that if I have an application, let's think about a standard like microservice application. So I have my application spread across different pods in my cluster, which could be the same node or different nodes. And then I want to make sure that I have, and this is the number one use case, I have mTLS enabled. Well, for that, something like Istio can 100% take care of this type of scenario. Again, I have a service mesh on top of my service now, or my microservice spread out, and then I can encrypt traffic between these different components. So security or encryption in transit is guaranteed at that point in time. But Istio does a lot more than that. Although that is the number one ask for customers, Istio can actually do load balancing. Istio can actually help you out with things like rollouts. And there's add-on softwares you can put on the side here to help with that. And Istio also provides some very interesting telemetry and visibility on your cluster. We're not going to do that on this lab, so maybe a future lab, but there is a component, I'm going to leave you with this name now, called Kiali. And then Kiali with Istio will allow you to actually see the flow of traffic here, that's TCP or something else, going into your cluster. So quite powerful. Now, it used to be that we had an issue here. Like if you do want to have this amazing capabilities, this advanced security capabilities from a network perspective, you have to roll out your own Istio and install it on a cluster. A lot of organizations are not there yet. They don't have the skill sets in house to overtake this challenge. Although, again, they still want something like mTLS. Well, with the add-on that we have here for AKS, I'm going to say that that learning curve of maintaining, making sure that a specific version of Istio works with a specific version of Kubernetes, that's kind of like taken away because our engineering team is putting the effort to make sure that that's hashed out and that it does work with AKS. I'm pretty sure we're going to have some questions here about, and I'll I'm going to be looking at the chat here. I saw some folks sharing out from where they're from. Yeah, I would love that if you want to put that in the chat. I'm coming today from Calgary, Alberta, in Canada, where, believe it or not, it's summer and it's raining a lot, actually. So yeah, shout out where you're coming from there. We'll be sharing the link for this, but this is in the AKS Labs. It's a link we've used before. Thank you, Anna, for dropping that link here on the chat. This is 100% hands-on. So we're gonna go from where I'm showing you right now into a terminal very soon. So if you can, just open up your terminal there on the side, and we'll start typing in a second. As I was saying here, we primarily have three objectives today. So let's enable Istio on AKS. As an add-on, if you haven't done that, this is a great chance for you to do it. We're gonna deploy a application that's the AKS store demo. That's our favorite application. A lot of us at the Global Black Belt team, we use that when we're trying to look at how a well-architected application can be deployed and work. And it's a real application, so put that in the cluster. We're gonna turn on mTLS on that, so I'll show you how that works. And then the last step is we're gonna expose that to the internet through the Istio Ingress gateway. There's a little bit of something that I want you to know about, and it is on this document, so you can follow that link here. Not everything that we have today on our add-on maps out to the open source version of Istio. There's some things there that are not in there. A list, an updated list, I wouldn't be able to do justice here, is available on this link, and I encourage you to go and look into that. Again, we do feel that for the majority of scenarios out there, what we have today will suffice. But if you feel like, hey, it's missing a component here or there, we would also love the feedback. So please keep that in mind, and then we can work together on that. Okay, getting our lab ready here. The prereqs are pretty simple, to be honest, in this case. You do, of course, need an Azure subscription. Azure CLI is the tool that we're going to be using here. kubectl, and then a terminal emulator. I'm going to be doing this on Windows with the Windows Terminal and WSL, the Windows subsystem for Linux. You can do this in Cloud Shell. You can do this on a Mac, and you can, of course, do this straight out on a Linux distro. This will work. But just so you know, like I'm actually using Bash as my shell. So if you're using Corn Shell or Z Shell, you're gonna have to do some, small changes there. And if you are using one of those shells, you probably already know what I'm talking about. For this lab, and there's a few labs that we're kind of following this standard where I will be creating some files, right? And then what I want to tell you is this. I would encourage you to follow some of this practice here, which is I'm going to create a directory just to save all the files there. It helps you to keep things organized in your file system. And then later on, if you have to delete it, it's also easy. I'll show you there is a little file that I'm going to create with all of the variables inside. So with that, I'm going to do a couple of things in here. I am just going to get out of full screen mode here for a second. And I'm going to welcome you to my terminal. We probably don't need two right now. I'm going to exit from one of them. And let's try to do a split screen here so you can kind of see. There you go. And hopefully I'm keeping an eye on our chat window just in case there is any questions in there. So the first thing here is we're going to create a directory called AKS Labs. You can always just copy. Okay, there's a little copy button in here. And then we're going to cd into the networking Istio Labs. Now, if this is the first time you're doing these labs, just as a hint there, you can see AKS Labs, and then really like the category, in this case, networking. If you go on the side here, on the sidebar, you can see I have others. So as we are building these labs, I would encourage you to kind of have that structure, helps you with your learning process. I already have created that, so you can see I have a directory here called AKS Labs Networking Istio Lab. And then the next thing I'm suggesting here is, hey, let's create a environment file called envrc. Um, Mine actually looks exactly like what you have here on the screen. We're doing a few things. Number one, we're getting the resource group name. In this case, I'm putting RG-AKS labs. Then the location. Now it's important that you use a location that you have quota. It happens that I have quota on West US 3. You might have quota on East US, East US 2. So change this variable here. And then the cluster name. I'm just using AKS labs for that. The next step here, I'm actually sourcing this. So I'm going to run this now so you can see it. So two things. We're going to just read my envrc so you can see that. Um, don't worry about the kube config. Yours will look like mine here in a second. I'm going to source that. So if you're new to Bash here, what we're doing is we're loading those environment variables in memory. I can reference them now, which is pretty cool. So if I do actually an echo here, just real quick on name, then I have that. Now, there's another reason why I'm doing this. And you can see I have all of these different directories. It's because every one of these labs will have nuances. Like some of the labs we're doing here are around platform engineering. Some are around CADA and event-driven architectures. Some are around observability. Now, you might have different clusters for this. So the reason I have this .envrc separate is that I can load it when load this file when I go into that directory, and then I have a context which is tailored specifically to that lab. That actually is the same way that I work with my own clusters. So I have that separate with this little file. Okay, now that we have that, we're gonna do a couple of things. We need a resource group to be created, and then az group create is the command for that. You can see I'm putting the location and the name of the group. And then the second command is this one, AKS create. It's a very simple command. So AKS create with the cluster name, the resource group that we just created. For this lab, we only need one node. So there's no reason why I would create more nodes. This is definitely not production. That's a separate conversation. For this, one lab. And then I have a couple of flags in here. One is to enable the Azure Service Mesh, ASM here. That's just gonna install now the Istio add-on. So it's super simple. With this, I already have all the components that I need. If I don't do that, so if I have already a cluster, I can actually enable the Istio add-on after, but it's a separate set of commands. You would have to do an update. I'm gonna disable SSH. I love SSH, use it every day, but we don't need it for this. And again, it's probably how you want to do it in production. You're going to disable it. Although I am generating the keys here. I will enable SSH if I have to, but I don't need that at this point. While the cluster is running here, I'm just going to go real quick, see if what we have here on. Okay, I see Alex is coming from England. Hey, Alex. Nice to have you here with us. See if there's any other questions for me here. Oh, I think we're doing okay. And then as the cluster is getting created, I'm just going to go down here so you can see it. There you go. We're going to get our kubeconfig credentials so we can start working on the cluster. Again, I do think that, and you will see that we're going to echo that kubeconfig into the .envrc. I could use the global kubeconfig file under your home directory in the kube directory there called config. But because this type of labs tend to be transient, I tend to remove them and then retry again, try a different set of options. So as I'm learning, I don't like to put that on my global kube config because then it's something else that you have to go and remove the entries from it. Whereas here, they're fully separate. One lesson here while this is creating, notice that I do have this file called .envrc. You could have called that anything, but there is a specific reason why I'm actually calling .envrc. There's a little secret here, which is I use another set of tool called dir-env, and I can drop the link to that on YouTube here on the chat. What dir-env does is this. If it detects that .envrc file, it will automatically load that into memory. So if I cd into this directory, it will load it up, and all of the environment variables are in place, including my kubeconfig. If I cd outside of that directory, then it removes that from memory. Again, super handy. Behind the scenes, the way this works is that you hook it up. There's a specific mechanism that you put on your .bash rc file. So the file that bashes uses when it comes on, when you open a new terminal here, bash will source that file. And then with .envrc, you're able to do this kind of handy operation. Again, if I have, let's say, 5 different clusters, if I cd in one of them, I can just load it up. Of course, the other way to do this is you just change the context. You do either to kubectl directly, or a tool like kubectx will also do the same thing in effect. But this one, I found out that it's just less typing. You just cd, and then off it goes. So I find that to be quite handy. Okay, I feel like we're almost done there with the cluster at this point. And while I let this run here, let me just open a second terminal here. Just in case we needed to here. Just kind of, while this is running here, I'll show you what I'm talking about here. So if you go to AKS Labs, you can see I have this message. So I'll put this full screen first. That loads all of these variables, because those are, for my own use case, those are common things that I use everywhere. And then, of course, you can see I have a different directory. So let's say I just pick the platform engineering here. So in here, this might be the one that I just knew. Let me just go back one level here. Operations, advanced observability. So let me do this again, and it might be too small on the screen. Advanced observability, and you can see just loaded up specifically for the cluster that I have created for this lab. Again, it could be that you have like multiple clusters in, and that's how it's going to work. Okay, so our Istio lab is actually, our cluster is deployed on the Istio lab. I'm actually going to navigate there. We can use this later on to help us. Istio lab, okay. I'm going to move up to this screen. All right, so cluster is ready. But for us to actually do anything with the cluster, we need a kubeconfig. So I'm going to run this command here, AKS get credential. Okay, and you would do this here too. You can export that into your file. I'm going to run .env. Again, this is probably just for me at this point, and load it up. So now I have all of the variables for this specific environment in memory. Let's double check. There's various commands you can run. I just chose these two here. One is kubectl cluster info. Just gonna make this tiny. Okay. We can see right now that I have one node, which is what we wanted. It's been up for about 3 minutes. So we know it's working. Let's also check, because remember, we already have Istio. So this took a little bit more time than your typical cluster, because I'm essentially installing a lot more components from Istio in it. All right, so we do have Istio, and you can see it's ready and running. Fantastic. Let's talk a little bit about the application we're going to be deploying this cluster. I did mention this is the AKS store demo. We tend to really like this application. I was part of the original Global Black Belt team that developed another set of application where this is based on, what's called Red Dog. Actually, those will be a good quiz question. Why would we call it Red Dog? If you know it, if you want to drop it in the chat there. So AKS store demo will have microservices. You can see we're using all sorts of languages in here: Node, R, Go, Python, Rust, sorry, Go. We have MongoDB. We have RabbitMQ, this is all in cluster. And then we have a front end and then a store admin. I'm going to deploy this now. It's going to be the most simplistic version of the deployment, which is like an all-in-one. There's other ways to do this. For now, we need to copy this line here. So one, we're creating the pets namespace. It's a pet store, so we're creating that, and then we're deploying all of the components inside of it. After that's done, you can check. I'm going to clear my screen here again. We can check if things are running. Okay, you can see some of them are still coming online. Some services are also coming in. I'm going to make this a little bit small. Let me know if this is too small in the chat. I'm happy to increase the font size. But all in all, what we're looking at here is just to see the overall status of the application. Is the application up and running, or do we have anything in a crash loop, or any other reasons here? I can see that there's a couple of things that are not up yet. So I'm just gonna try this one more time. And it will probably come here in a second. That's the order service, which it's not something that's gonna stop us from proceeding. So if you end up having something like the other service and it's still not up, it's okay. You can actually run this in a watch. Mine is up now. I can see they're all one in one. There are two ways to do this actually, just real quick. You can do a -W, not for that one actually, because I'm getting everything. If I get all the pods for the, so let me show you this here. Dash name pets, and then I do a -W. That's gonna keep going in a loop with watch. Another way to do this is just to actually call the watch utility in front of it and then run it. This seems to be the preferred way. I know Steve from my team likes this way. I kind of like that way too, especially because there is a flag called -D that will show the difference. So visually, it's a lot easier to see. That's why I tend to like that too. So just run watch in front of your command. Okay, at this point, we should probably all be on the same page here with everything is up and running. In fact, let me show you something before we proceed. I'm going to do a, so I have an alias here, K, instead of typing kubectl all the time, in case you have to do it, it's alias K equals to kubectl. So little tip there. So K get PO, sorry, not PO, service, SVC, on the pets namespace. You can see I have the storefront. I'm interested in that. There's an IP address. I just want to check if the store is up and running. It should be. All right, there you go. So that's our store running on our cluster. Now, we're going to do a couple of things in here. Because it deploys the service with a load balance, we have a public IP address. I don't want that a public IP address. We're going to use the gateway API later on with Istio. So what I'm going to ask you now is to change this. We're going to remove both from the store admin and the store front. And I'm going to do this live with you here. The way to do it, there's a few ways to do it, but I'm going to show you how to do it live. And that's how we're going to do this. I'm just going to edit. So kubectl edit service. You can actually point this out to the whole service, and it will take both of them. Okay, I'm looking for the type called load balancer. Okay, so this right here, I can see that the app is store admin. I'm going to delete this. And then I'm going to call this cluster IP. And then just here on VI, I'm going to do next, which is the letter N. We're gonna delete that too, because this one is a storefront. So again, a little bit of VI here. D and $, deletes everything. A will append, and then we're gonna add cluster IP. And let's see if we can escape VI. Boom, we can. Okay, so there's a few things, two services here that we added. We're just gonna double check that that's still valid. So kget service dash n pets, and they're gone. So the reason, again, the reason for this is that I do not want this to have a public IP address. Okay, so if we go here now, this should just fail. It's gonna go in a loop and timeout eventually. So we remove that. The next thing is this. Now that our application is deployed, but it doesn't actually have anything that is public facing to the internet, we will, on the second stage here, enable that. So we're gonna enable that again. So just put that aside for the time being. Um, what I wanna talk to you about now is this. Traditionally, when we actually have to enable a service mesh, you would have to have a separate container here, right? These containers are typically called a proxy or a sidecar pattern. That's a very common terminology. They will then get a policy, and then that policy, which is like a secure policy, will allow your application to communicate with one another. For us here, there's a few things, and I want you to be mindful that with time, I expect this lab to be outdated. And the reason for that is that we are increasing Istio, the version that we support. So if you're looking at this video in the future here, hello from the past, you will see that I have a revision for Istio here. I will make sure that this gets updated, but if it doesn't, between the time that one gets out and this is not updated, know that you have to change this. That's the only thing I'm gonna say now. Let's take a look and see what version of what revision of ASM we have for Istio. As of this writing here, since I've updated, so you can see I'm not lying to you. This was done last week, so it's 1-25. We're gonna change this together now. Again, this is super recent, and then you can see the change here is 125. That's okay, which is a good example here. I'll show you how to go about that. What we're gonna do next is we're gonna enable Istio on that specific namespace, that pets namespace. That's where our AKS store demo is deployed. You can see I have a label here. So I'm gonna copy this, but I'm not gonna apply. And the reason for that is that I need this to be the 1.25. Of course, I could make this into a variable, but I think it defies the purpose of learning. I want you to actually see, because you might see that in production. You might see that, hey, they changed the version here, which is fine. That's what we expect. So let me actually do this. Let me clear my screen again. This is the command that I have in the docs. Okay, we're gonna change to 1-25, which is what we actually have in the cluster. I'm gonna apply this label now to that namespace. So what we're doing at this point is that we're telling the ISO control plane that it's enabled for sidecar injection on the deployments on that namespace. So we are gonna use this sidecar. But for this to actually work, let me show you something. I'm gonna have to do a rollout. I'm gonna restart this pods that I have in there. You can see right now I have 1 out of 1 ready. Everything looks okay. I will do the rollout now so you can see how that's gonna work out. And you can see everything is coming back. And the way to do it again, we're gonna tie back to our conversation about watch. And then watch will show us that things are terminating. See, some of them are 2 out of 2. They will all be 2 out of 2. Some of them are just in terminating, some of them are already in running state, right? Now, the other thing that we're gonna have to do here, we have 2 stateful sets for this specific application. I'm gonna do a rollout on both of them. One is the MongoDB and the other one is RabbitMQ. While this is finishing, you can see like some of them already in the state that we want. They're only like 50 seconds old. While this is running, let's do the rollout for the stateful sets, the 2 of them. And then we can double check now with this command, which is kubectl get pods, stateful set. So that's essentially going to do both the pods and the stateful sets at the same time. They're not there yet, so maybe we do a watch-d. So these should show us all of the difference between the two screens when this is taking care there. Let's see. It's coming online. It's expected that some of this might have an error there because they're dependent on MongoDB or Rabbit to come online as well. That's okay. We'll just let this get stable there for a second. And then I want to show you something else here, which is how do I actually know that this is working, right? I've enabled it, but we don't know for sure. So all of my pods, they do look okay. Let me go back here. Just cancel that out. So one way to do this is if you describe, you can pick any one of these applications. I'm just going to do the storefront. If you describe any one of them, and you can see on my output, I have some events. Well, let me put this full screen here so you can see. On the event sides here, you can actually see a couple of interesting things. One is that we're now pulling the Istio proxy v2 image, right? You can see that it was pulled successfully, and then now I have a init, an Istio init container. So they're coming together in the same pod. The beauty of this now is that I didn't change anything. I didn't change any code or anything like that. And then I know now for a fact that Istio, with its Sidecar injection, is actually working on this namespace. And we're going to verify that. If you do scroll up here, you will see they have a lot more information around Istio. Wasn't there before. And we know that this was actually enabled. So you enable on a namespace. That's what we're actually doing right now in here. Okay, so let's just move this to the side here. Now, and again, your setup might take a little bit more time, but eventually you should get into the same level here where if you do a describe on a pod, for instance, you can actually see the Istio sidecar. Now, let's look at, again, the number one, if I had to cherry pick a topic here for Istio, would be mTLS. So mTLS will do a couple of things. It will do encryption in transit, it will do authentication, and then I also have something called the zero trust security, which means this. Imagine somebody was able to get into a pod, maybe gets a shell, a reverse shell into a pod. That pod is not a part of your Istio secured mesh. Well, it turns out that from that pod, an attacker wouldn't be able to just go and reach out, let's say, to the storefront in our application here. Um, and the reason for that, we're not allowing that communication to happen as part of the mesh. By default, Istio will allow you to do a couple of things here. One is you can do plain text, which is unencrypted. We already have that. And you can also do mTLS. Now we're going to do something called a strict mTLS. So if you're not doing mTLS, then that communication won't happen. We're going to cut the flow and essentially going to stop or block the communication. For this, I need a policy. If you recall, there's a chunk of this document here that describes how a sidecar works. And one of the components of a sidecar is that policy. We need to have a policy in place. That policy dictates how the communication works. We will do a couple of things here. One, we require mTLS for all services on that specific namespace. In our case, the pets namespace. We can allow this permissive mode, but that's not what I wanted to happen here. And of course, you can disable mTLS, which is also defies the purpose of this. So let's do this. We're going to create a peer authentication policy. And then with that, we're going to enforce it. So from outside of this namespace, on the default namespace, I'm going to create a curl pod. That's the curl pod right here. Okay. What this did do now is, and you can cat this. We're gonna just do, it's a basic curl image. It doesn't do much. We're gonna apply that and we're gonna do some tests right now. So I'm gonna apply that. And then with this command here, we're gonna get its IP address, and we're gonna try to hit the storefront through its cluster IP. And you can see in the message here, scoop up a little bit, you can see that we're getting that back, because really at this point, I'm allowing the traffic to happen, right? So a 200 OK is what we wanted because it's accepting unencrypted traffic. This is, at this point in time, business as usual. Nothing really changed here, but we're about to change that. We're gonna create something called a peer authentication. And that's the kind, you can see that in here. Specifically on the paths namespace. And for the mode, I'm gonna go for mTLS strict, meaning that the pod, the one that I just had right now, won't be able to communicate with my application in the paths namespace because it's not a part of that namespace and it's not using mTLS either. So once I apply that, I actually now have a policy in place being enforced. So if we test this again with, let me clear my screen here, with the pod sitting outside of that namespace, you can see that I'm having a code 56. A code 56 means there is a failure here or connection reset by peer. You still won't accept this communication because it's not encrypted, and it's actually not encrypted with the mTLS inserts of the pets namespace. So it does fail that. We're just gonna drop any plain text sort of communication. To test if this is actually working, because it could be that I'm just blocking all traffic, which is a good troubleshooting practice here, because maybe your policy is too strict in nature, and then you're just dropping traffic left and right. So the way to test this is to create another, for our case here, another curl pod, but now inside of the pets namespace. You can see I actually have that specified in here. I'm going to apply that. So we're going to run the, here actually, I actually had a command in there, which is kubectl apply -f, the name of that file, curl inside, and then inside of the pets namespace. Once that's running, we're going to do a couple of things. You can see I have curl inside pod, so we can get its name. Just a fancy way to do the same thing here. We're essentially doing a kubectl exec. So I'm execing into that pod, and then I'm running a curl command from the pod that sits inside of the pets namespace. Because that communication is now in a mesh and it's fully encrypted with mTLS, this will work. And you can see that down here now. So the only reason this works is because that pod sits inside of the pets namespace. And Istio will allow that. So cool, that's the first part of our hands-on lab here. The second part that we're gonna be looking at is, remember we had a service type equal to load balancer, but I removed that. And we can actually check this in here. If I do a keep get service -in pets, that's no more. I don't have an external IP. So my application, as cool as it is, I really can't let the world access it, right? Our store here, you can see just timed out. So we're gonna do a couple of things here. We're gonna enable the Istio Ingress gateway. And with that enable, we're gonna create a couple of components, and I'll walk you through that, that will now allow secure traffic from the internet directly into the store front in our case. For us to enable the Ingress gateway, we're gonna do this through the AZ CLI. I'm gonna go back to the AZ command. So you can see AZ AKS mesh, which by the way, if you had to enable the whole thing from scratch, this is your friend. So you're gonna use AZ AKS create or update, and then AZ AKS mesh. That set of commands will help you get where we are right now. I'm gonna copy this command here, And you can see that I have an ingress gateway type of external pointing to my AKS cluster with the resource group as well. Once that's enabled, you might not immediately see this happen. It might take a minute or so here. We can check in the Istio Ingress, that is an AKS Istio Ingress namespace now. We should have at least one pod running there that will resemble in what we see in this here. So I'll let this run. And while this is running, I'm going to go to this other shell here. And let me just copy this command so we can kind of try to see if we can follow this in real time, or somewhat of real time, if you will. There's nothing there just yet. I'm going to do a watch, and maybe I'll leave that running while that's going here. Just going to double check that we don't have any other questions. Nope, looks like we're okay. So we'll let that finish. Our pets are still fine. They're still running. Let me double check the stateful sets. Still okay as well. So I did for both. And then I can also, just while we're waiting for that, I can also just do a get an S here. So Istio ingress, egress, and system. So those namespaces are in there. I can see that some things are already coming online at this point. They're there just shy of 20 seconds. I'm gonna let watch run here. Okay, so that's done, and we can see those two pods that are running there. Cool. Now the next thing is this. We gotta define, so the gateway resource listens on port 80, and it's gonna forward the traffic to the storefront. You can see there is a new kind here. The kind is called gateway. So keep talking about the gateway API. In it, there's a few interesting data that I think you should pay attention. One is that we have the selector here that's going to match with the one that we just created. And you can see the server port. So on port 80, the protocol is HTTP, and we're just sending that to any host there. Once that's created, please go ahead and apply that. I did put this call out here so you understand a little bit more, because I'm just especially with timing. There is a selector here, and you see that the selector that I had is this one called AKS Istio Ingress Gateway dash external. That will actually match, and I'll show you this now. This will actually do a matching to the Istio service. So if I do this describe, we should have a label right up here. Okay, so that's how these two are matched together. So when I do create a gateway, I'm now matching to this label here. Again, something to pay attention on, because maybe you're like turning the gateway on and for some reason traffic isn't flowing. Double check that selector label there matches what you actually have today on your Istio service. Okay, cool. Now that we have the gateway, we need to do something else called a virtual service. A virtual service will actually do the routing of the traffic here, right? We can see that it is also sitting on the pets namespace. The gateway is called pets gateway, which is the one that we just defined, right, in the previous step. I'm matching on just slash on the URI, and then I'm sending that over to the storefront. Remember, the storefront is a cluster IP at this point, so we have no other way to access this other than the one that I'm showing you right now. So we're creating first this pets route, and I'm going to apply that, kubectl applied, on the namespace called pets. Remember, we're sending that over to our pet store. The way to find our IP address for the Ingress gateway is a service, so I can just look at that. That is our IP address, and we can test it now. So this one works. Okay, demo gods were good with me today. It did all just work here. And to be quite frank, this is very stable. I've tested this hundreds of times, probably more now. Um, I do like this interface. In fact, I actually like this a lot better than your previous Ingress with Nginx. I just think that this setup is a lot easier to troubleshoot, especially if later on you have Kiali on top. That really makes a difference. And again, maybe that's a topic for a separate lab. I'll do the same thing here from the command line in case you're like me and you prefer the command line. So you can see that that's working as well through curl. But that's it. I mean, at the end of the day, um, you are doing some interesting things here. One, you're enabling mTLS on an application. We didn't change the application at all. We're doing that through Sidecar injection. And we're now also using the Istio Ingress gateway, which is quite powerful. I barely scratched the surface on this here. There's a lot more information on Istio. I'm going to leave you with a few ideas of what you can do next, where you can take this knowledge next here. I do encourage you to go further. Few things here. You can actually, and that I've linked this into some of the Istio official documentation, like traffic management, like fault injection, or if you're doing canary deployments or blue and green. I do feel like there's value. There's a lot of value in this. Go ahead and I would say spend some time looking at that. The whole conversation around authorization policies, there's a lot more than can be done here. Again, I just kind of touched the surface on that. You can, if you want to, let's say you don't want to use Kiali, or you can use Kiali. There's a lot of stuff that you can do with Prometheus and Grafana. We actually have a lab on advanced observability. You can look into that too. And you can get some of those metrics and flow that up so you have in Grafana. There are other things about how you scale. How do I go about when I have to upgrade Istio? Also encourage you to look into that. We have some very well documented information around that. You can see here performance and scalability. I'll leave you with that information as well. And then from here, there are other things in the catalog that we can do. If you wanted to delete this lab, we can do it right now as well. You can do an AKS delete, and then that will remove the whole lab. I do want to call out a special shout out to Richard Hooper. He is Pixel Root. You probably know him on Twitter or LinkedIn or Blue Sky. This lab is essentially based on a lot of the hard work that Richard put in place. So Richard, thank you from the community. And then, I took over on some of the stuff and just updated. And you can see the pace of things in here. I probably have a new update coming up today with the latest version of Istio. And I also want to say thank you to my teammates, Paul, you, and Brian Redman, Steve, Megan, Jim, Joey, everybody that actually helped me out with this lab. It takes a lot of effort to get us to where we are here today, but I do appreciate it. I'll look into the chat here to see if there is any other questions. Let me just and I'll leave you with that. For the questions here, let me just see. Is there any additional cost using? No, there is no additional cost on that. There was a question from Gilbert, I think. Yeah, no. Um, Thank you, robot clock. I don't know what that means. What do we need to consider when we want to build system at scale using Istio? Great question. We actually you should look into this here, and this is the last question I have here from Curti. Look into this because this will talk about a couple of interesting things. One is what is the performance and what skills were the engineering folks using to test it out. So again, I think that's where I would start there. We also recommend there's a recommended network plugin for large clusters. I'll link to that here, and I can speak about that in a second. But look into this. I'm going to say this is probably where you want to start. There's also a latency comparison across the different versions. I also highly encourage you to look into this. Pay attention to the SKU size being used for that as well. Now, overall, if we take a step back and we're talking about production, that is, let me go up here. There is a document where we specifically talk about what sort of knobs and tweaks that you should be taking into consideration when you have large clusters with AKS. And by large clusters, I mean this is like a 5,000 nodes or more. This is typically quite large. Probably the number one thing you need to think about here is the type of networking you're going to be using. And then for this, we will go with the Azure CNI overlay mode with Cilium. That's a lot faster here and uses eBPF in the data plane. Again, I do encourage you to look into this doc here because it has a lot more detail. Would love to jump into a call as well and go into the minutia there. That will add value when you have Istio with as your component. And I think it's different strategies there. But for Istio, specifically for Istio, they have these three documents here. One is on performance and latency comparison. So I would say that's where I would start if I'm running this into production. But this is an excellent question, by the way. Can you use a network policy in combination with Istio to limit communication between pods? Oh, that is an excellent question, Kirk. Can you use Yes, would I use no? Because I think it makes your life a little bit more complicated than it should be. I think what I would do here, what my suggestion would be is, what can we use Istio for today that it's already in there that would help us out? So if you go up here in this document from Istio, themselves there around traffic management, you can do some of these things in there. Now, you mentioned network policy. I'm going to assume that's just a vanilla Kubernetes like network policy. If I had to do something here, and if I'm not doing any sort of traffic shaping with Istio, boy, I think I would go with Cilium because this is the one that we're recommending there, and then maybe have some rules on that level. But again, yeah, that's a very pertinent question there. I think the other thing that nobody asks, so I'll just say it now, is ambient mode, which by the time of this recording here, it's probably already coming, and I think it's the next level here. I do feel like the whole idea of the sidecar injection makes your life just way easier. You're not changing anything. But then eventually, what you were going for is just turn on ambient mode and be transparent, and then call it a day. I think that's the next level of where we're going here. So these are all very good questions. I'm gonna leave with this here too because we do have some other things around Istio on our docs, and again, a lot of this is in flux at this point, and but it is GA. It is a GA component that you can just use. Well, I'll keep an eye on the chat here, but that's it for this lab. I mean, I'm happy to take any other questions. You can also reach out on LinkedIn. I'm happy to answer those in there as well. But I hope you had a good time here today.
Thank you so much for joining, and thank you again, Diego. Our session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link that's on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.